Greetings everyone. Today we are going to explore solving systems of equations by elimination. But specifically in this video, you are going to need to line up your equations, and our solutions are only going to be special solutions. If you're in my class, make sure you're on the right set of notes in the right video. If you're not in my class and you're looking for something different, make sure to check out my YouTube playlist. Since this is the last lesson on elimination in my class, we want to make sure to add some steps to our notes. So find the location to jot these down. Remember, these are my steps. In other words, they're kind of generalized. They have some interesting vocabulary, and you might have learned this another way or with another teacher, and that is completely fine. I find these steps the easiest. Step 1, we want to arrange the equations in the standard form, which means x, y equals number. That requires some moving around. Step 2, we want to choose a variable to eliminate. Are you choosing the x's or the y's? This might require some multiplication. Step 3, my favorite, I like to call it old school addition. Draw a bar and add your columns. Step 4, after you've done that addition, you'll have a little bit of an equation to solve. Once you've solved for that variable, step 5, you want to take that number, plug it in to find the other variable. Make sure if you need to, pause this video at any time. Let's go through our steps. Step 1, I'm going to encourage you to arrange all of your equations into that standard form, meaning x, y equals number. So if I look at the first equation, see how it's already in the order we need? Perfect. Or if I look at the second equation, the y's on the left side, the number's on the right side, but the x is on the wrong side. I need to kick it over the line, is what I like to say. And so instead of positive 5x, if it jumps the line, it becomes negative 5x. I do the opposite operation. That means my new equation has a negative 5x. It still has a negative 20. Still has an equals, and still has a negative 15. I'm going to rewrite the first one. The first one was already in order, and I like to see them lined up. Step 2, we want to choose a variable to eliminate. I'm going to choose the x's because they're smaller numbers, but you could use the y's. When I look at the x's, I can't make a 2 a 5 or 5 a 2. So this is an example based on our previous lessons where I need to multiply both equations. I'm going to multiply this first equation by 5, and I'm going to multiply the second equation by 2. See how I use the opposite numbers? Also note, the signs are already opposite. One's positive, one's negative, so don't worry about signs on this problem. My new system, if I distribute to every term, 5 times 2, 5 times 8, 5 times 6. Let's take care of the bottom. 2 times negative 5, 2 times negative 20, 2 times negative 15. You can see where this lesson of special solutions comes into play. Step 3, this is Mort Vet's old school addition. Positive 10x plus negative 10x cancels. Uh-oh, positive 40 and negative 40 also cancels, but I need something. So if everything disappears and there's nothing there, we can put a 0. Positive 30 plus negative 30 is also 0. Is 0 equal to 0? Everything canceled. Is that a true statement? It is. That means we need the words infinite many solutions. We've talked about these words in previous lessons. The benefit to these special solutions is look how short that was, right? Because everything cancels, we don't have to worry about step 4 or step 5. Example 6. To start this example, we need to write our equations in the correct order. The first equation has an x that's in the perfect spot. So I'm going to start by writing it out. But my y is on the wrong side. So instead of minus 3y, I have to kick it to the other side and do adding 3y. So I'm going to have a positive 3y on the left. I then have my equals and the 4 remains where it is. My second equation, it's already in the perfect order. So let's just rewrite it. Now in front of each of those variables, I'm going to write a 1. That'll help me in the future. Step 2, we need to choose a variable to eliminate. I'm going to choose the x's just because they're first. I have a 3 and I have a 1. Well, you know what? I don't even need to multiply the first equation. Let's just take care of the second equation. I can make that one a 3 by writing a 3. Uh-oh, they're both negatives. And if I need something to eliminate, I need to have a different sign. So let's make this a negative 3. Let's distribute negative 3. Negative 3 times negative 1x is positive 3x. Negative 3 times positive 1y is negative 3y. And negative 3 times 3 is negative 9. And then I'm just going to rewrite the first equation. We didn't do anything to that first equation. It's still exactly the same. Here's my new system. Step 3. Let's do some old school addition. Negative 3x plus 3x cancels. But so does 3y and negative 3y. So in this lesson, in this task, you should always end up with a 0 on the left side. On the right side, a 4 and a negative 9, that adds to negative 5. Is 0, because all the letters disappeared, we have to say, does 0 equal negative 5? No, it doesn't. That means there is no solution to this system of equations. Alrighty, let's take a look at example 7. Step 1, we want to arrange our equations. The first equation is in the perfect order, so I'm just going to rewrite it since I like my systems to be next to each other. On the second equation, however, the y is on the wrong side, so if I'm going to kick it to the other side of the equation, I need to do the opposite. So we are going to arrive at a negative 3x. We still have the positive y, and we still have the positive 2. Step 2, choose a variable to eliminate. My eyes are drawn to the x's only because they're out front, but you could also do the y's. If you look at the x's, I can make that 3 a 6 with just a 2. The signs are already opposite on the x's, so that's taken care of. Let's distribute. 2 times negative 3 is negative 6x. 2 times 1 is 2y. And 2 times 2 is 4. Now I'm going to bring over that first equation because I didn't do anything with that again. Remember, each time I've written this, it's the exact same system. I've just arranged it or made the equation triple or double the size depending on what you're multiplying by. Step 3, time for old school addition. If I take a look at what happens. Positive 6x and negative 6x cancels. Negative 2y and positive 2y cancels, but I need something, so let's say 0. Negative 4 plus 4, that's 0. Is 0 equal to 0? Yes. That means we're going to write infinite many solutions. Example 8. Let's start by rearranging. In the first equation, the y is on the left, but the x is not. So I need to add 2x to kick it to the other side of the equation. So as I write my system, that means I have a positive 2x, a positive y, and a positive 2. Look at the second equation. It's already in order. So I am just going to rewrite what I have. Step 2, choose a variable to eliminate. Well, I'm looking at the x's and they're already the same number, but unfortunately they're not the same sign. So I'm going to choose one of the equations, either one, and I'm going to multiply it by -1. If I distribute -1, I get a -2x, a -1y, and a -2. I did not mess with the second equation, so I'm just going to rewrite it. Let's draw a line down the equals and do some old school addition. That means -2x plus 2x cancels to 0. -1y plus 1y cancels to get 0. So let's write a 0 because I need to have something there. And -2 plus -2 is -4. That means this is another no solution. A couple more things to note. Now, you do not have this in your notes. You will see this in your homework. And so I just want to discuss it. And when I'm done with this slide, it might be a good place to pause and just leave on your screen as you work on your homework. And I just want to talk about a few arrangements, okay? The first type of arrangement that was not in our notes, and I just want to show you for when you encounter it, is an equation that looks like this. See how x and y are together and the numbers by itself? That's what we want, right? We want everything to be this x, y equals number scenario. But if it's all good, we can actually just rotate around the equal sign without changing signs. See how it's just a clean rotation around the equals? So there's something that doesn't require more work. Let me also throw out this scenario, as I know you will see this. What if I have the number, then an x, then a y? You might have to move two things. I might have to kick the 13 over, and I might have to kick the y over. So let's see what that looks like then. The positive 5x, we never moved it. The -4y and the -13. You will see this where you have to move two things. And the third type you might encounter is what if just the y and the x are flipped around, but the equals and the number are good to go. If that's the case, the 10 stays, the equal stays, we just need to flip around the addition sign. Addition is commutative. You remember those words? That means we can add in any order we need to. So just flip the x and the y. Again, I encourage you during work time, come back to this slide, pause as a reference. Alrighty, make sure if needed, you go back to previous slides and pause as you work through your homework. For that homework, make sure to check out Google Classroom to see what your task is. Always make sure to ask questions. And again, consider going back to that previous slide, pausing it while you work on your homework. Take care, and until next time, have a good one.